Welcome to Study Loop.
42.16, we want to find the binding energy per nucleon of europium 152. We have this information about the masses of the europium atom, the hydrogen atom, and the neutron. So the binding energy is going to be the number of protons times the mass of a hydrogen atom plus the number of neutrons, which is the atomic, or is the mass number, which counts the total number of nucleons, minus the number of protons. And then from that, we're going to subtract the mass of the atom. This is the mass that you'd have if you just had a bunch of protons and neutrons all lying around without being bound to each other. And then the difference in that mass and the actual mass of the atom is going to be the binding energy when you multiply it by c squared. And this is the mass of the hydrogen atom and the mass of the europium atom. But the masses of all the electrons and the electron in the hydrogen atom gets multiplied by the number of electrons in the europium atom here. So those cancel out and we don't have to worry about it. Also, the contribution to the masses that the electrons make is pretty small. So, but technically this is a legitimate way of doing it. And we're not just assuming that the electrons don't exist. So if we call this delta M, we just put in all of our information here and find that it's equal to 1.34 to 418 atomic mass units. One atomic mass unit corresponds to 931.49, etc. mega electron volts of energy, or you can think of it as being per c squared if you want to be careful. So then the binding energy in mega electron volts is 1250.454 mega electron volts, not milli electron volts. And so the binding energy per nucleon, we just take this and divide it by the number of nucleons, which is the mass number, and we get 8.23 mega electron volts.